All right, everyone, here we go. Next part of section 3.5. On the first part of the section, we solved exponential equations, and now we're going to be solving logarithmic equations, which I actually think is the easier of the two types of equations to solve. So that's good news. Let's look at, first of all, the one-to-one property for logarithmic equations, just like we have the one-to-one property for exponential equations. And it's a pretty common sense property. It just says for any logarithmic function, if, well, I can't get my pen to work here. Let's try this again. Here we go. If log base b of u is equal to log base b of v, then u equals v. So it's just kind of like these logs cancel each other out. So if you have the log of 4 equals the log of x, well then x has to be equal to 4. So there are two basic types of logarithmic equations. The first type is the type where it's same base log equals log equations is what I call them. And you'll notice that on all of the problems on this first page, you have logs on the left-hand side and logs on the right-hand side. And those are even the easiest of the log ones to solve, because as soon as you get it down to a single log on the left equals a single log on the right, like you already have on number 1, you just use the one-to-one property and say, well, if the log of this equals the log of this, then these two things must be equal. So you just go straight to 4x minus 7 equals x plus 5 and solve. So let's see, that'd be 3x is equal to 12, so x is 4. Boom, easy. Same kind of deal over here. Log equals log, so we know that 5 minus x has to equal 3x minus 27. So if I add x over here, that would be 4x. If I add 27 to the other side, I would get 32. And then I would get 8 is equal to x. And I seem like I'm going along just fine. However, there is one snag with these logarithmic equations. You must check for extraneous solutions because you can't take the log of a negative number. Actually, you can't take the log of a non-positive number. So maybe we should change that because you can't take the log of 0 either. So let's change this to non-positive. So let's go back to these first two problems that we did. One of these is actually not correct. What you have to do is take your answer and quickly plug it back into the original and make sure that plugging that number in gives you a positive result. So 4 times 4 minus 7, yes, that's positive. 4 plus 5 is positive. So this one should be fine. Over here, if you plug in 8, you get 5 minus 8, which is not positive. So therefore, this answer is actually extraneous, because if I put in 8, I get log base 3 of negative 3, which is undefined. You can't raise 3 to a power and get negative 3. So therefore, this one actually has no solution. So you really have to watch out for that. Just remember to quickly check each one of the log equations. Now down here at the bottom, we have some in which we have several logs. So I have log, 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 and as you can see, I've got that in each one of these. When that happens, you first have to condense using the log properties. Usually you're going to use the product or quotient property, and sometimes you may have to also use the exponent or the power property. So let's see what we've got here. In number 3, we have two different logs on the left-hand side, so we're going to have to start by combining those. And this is the sum of two logs, so we know that's the log of the product of those. And 5x times 4 is 20x. Once you have a single log on the left and a single log on the right, you can use the one-to-one property. 20x equals 60, so x is 3. Quickly double check and make sure that doesn't make you take the log of a non-positive number up here. It doesn't, so I'm good to go. That is my answer. Over here on number 4, I have the difference of two logs. So there, I'm going to use the quotient property. So I'll have 3x over 2 equals 18, one-to-one property. So that means 3x is 36, and x would end up being 12. Double check. 3 times 12 is positive, no problem. 12 is the answer. Okay, let's come over here to number 5. There we want to combine, again, condense on the left-hand side. We're going to make that log base 2 using the product property of x times x minus 3 equals log base 2 of 10. Now that I have a single log on the left, a single log on the right, I can use the one-to-one property. X times x minus 3 equals 10. Distribute the x. Oh, it's a quadratic, so let's get it equal to 0. Factor. We need two numbers that have a product of -10 and a sum of -3. That's going to be, whoops, hold on. Well, okay, that's going to be -5 and +2. So we have x equals 5 or -2. Now we need to make sure that we go back and check and make sure that neither of these answers here make us take the log of a non-positive number. If I put in 5, I'm taking the log of 5. 5 minus 3 is 2. That's still positive, so I'm good to go. If I put in -2, however, now I'm taking the log of -2. I don't want that. So -2 is actually extraneous, and we just have the one answer at x equals 5. All right, let's look over here at this one. Again, we have two different logs on the left-hand side, so we need to condense that into a single log. I notice here I've got a 2/3 as my coefficient, so I need to use the power property and make that into an exponent. So that's going to be log base 3 of x plus log base 3 of 64 to the 2/3 equals log base 3 of 32. Now, 64 to the 2/3. Remember, that means the cube root of 64 squared. Since we're doing this in our heads, it's easier to first take the cube root of 64 and then square that answer. The cube root of 64 is 4, because 4 times 4 is 16, times 4 is 64. So this is really 4 squared, which would give you 16. So this 64 to the 2/3 is really just 16. And then you want to multiply that by the x, because you're using the product property here. So that would be the log of 16x, that's base 3, equals the log base 3 of 32. So 16x equals 32, which means that x is equal to 2. And double check, that doesn't make anything up there non-positive, so I'm good to go. On the second page here, in that first set of problems, it was log equals log. We had logs on both sides of the equation. Over here, that doesn't happen. We've got log equals value is what I call it. So notice you only have logs on one side of the equation. On the other side of the equation, you just have a value. So when you run across that, you're going to have to change from logarithmic form into exponential form. So let's look at number 1 here. I've got log base 4, 5x minus 1 equals 3. So you just, as soon as you have a single log on the left, you go ahead and change it to an exponential. 4 to the third equals 5x minus 1. And 4 to the third, 64, equals 5x minus 1. And then just do the easy algebra. 65 equals 5x, so x is 13. Again, quickly double check. 5 times 13 minus 1 is positive. No problems there. 13 is the answer. Over here, log equals value, so you'll have to change it to an exponential. Remember, the base of the natural log is e, so we're going to get e to the 8th equals x plus 3. Subtract 3 from both sides, so x is e to the 8th power minus 3. You can just leave it like that if you want to, or depending on the situation, you may need a decimal approximation. Let's see, if we have e raised to the 8th power, and then minus 3, that's approximately 2977.96. 2977.96. In case you needed a decimal approximation there. Let's go over here to number 3. There we would need to combine the two logs into one on the left-hand side. First, I'm going to use the power property and take this 1/2 and make it an exponent. So I've got log base 3 of x plus log base 3 of 25 to the 1/2 equals 2. 25 to the 1/2 is the same thing as the square root of 25, which we all know is 5. So really, we just have log base 3 of x plus log base 3 of 5 is equal to 2. Combine those into a single log using the quotient rule. Now we're ready to change it to an exponential. And 9 equals 5x. So therefore, x is 9/5. 9/5 would not make anything negative up here, so that is my answer. Over here on this one, again, we're using the product rule. So we have log base 2 of 3 times the quantity x minus 1, equals 5. So that would become 2 to the 5th power equals 3 times x minus 1. 2 to the 5th is 32. And distribute that 3. And then add 3. Divide both sides by 3. X would be 35/3. Again, 35/3 minus 1 is positive, no problem. All right, this brings us to our last problem in our notes from chapter 5. Here we go. Log of 2x plus the log of x minus 5 is equal to 2. So use the product rule again. So I'm going to multiply these. 2x times x minus 5. Change it to an exponential. The base of this one is 10. So we have 10 squared equals, and then go ahead and distribute the 2x. 2x squared minus 10x. Looks like we can divide both sides by 2. 10 squared is 100, but if you divide that by 2, you get 50. 2x squared divided by 2 is just x squared. 10x divided by 2 is 5x. So then you have x squared minus 5x minus 50 equals 0. Factor x minus 10x plus 5 equals 0. So you get x to be 10 or negative 5. -5 causes a problem up here. If you plug it back in, that's extraneous. 10's the only solution. And we are finished. Should be able to do the rest of the homework problems now. And that completes Chapter 3.